Okay.
Thanks. It's fine. Yeah.
Thank you. This operating GoToMeeting is not my, or WebEx is not my greatest area of expertise.
Okay.
Is to reach children with vitamin A tablets twice a year. So biofortification is potentially a complementary strategy that could really be sustainable for providing access to vitamin A and iron through orange sweet potato and high iron beans in a more sustainable way and potentially more cost-effective way over time once adoption rates are high. This is in some ways the greatest challenge for biofortification is to get those high rates of sustained adoption. And Harvest Plus has demonstrated substantial success. In some ways, when I presented this work, alarming success. People have been shocked at how well it's gone. But we also know that there's still potential out there, and that's really what this study is about. So this project that I'm presenting to you about today is the DDBC project, developing and delivering biofortified crops. Their Harvest Plus project in Uganda. It built on prior work in the Reaching End Users project, which was conducted in Uganda and Mozambique. Work from that project, which is on my third bullet here, showed that biofortified orange sweet potato is an effective strategy to increase dietary intake of vitamin A and improve micronutrient status among children and also among women for increasing dietary intakes. And this work for Uganda was published with Christine Hotz and a number of colleagues and for both Uganda and Mozambique, and also draws from Jan Lowe's work and her team back in Mozambique in 2007. So in some of the work that we've been doing, it's clear, and I've made the case in a separate paper, that that biofortification is going to require high rates of sustained adoption to be a successful strategy at the population level as a public health intervention to reduce micronutrient deficiencies and in a sense at least locally replace the need for supplements. And so there's quite a bit of sharing that goes on in these communities in terms of access to planting material and in some cases access to the actual crop itself. But markets so far for the biofortified crops, the market development, at least in the initial years, is quite slow. And so most households will not be accessing the biofortified crops by going to their markets and purchasing. So adoption, getting high rates of adoption and sustained adoption is really crucial. I'm going to show you a couple of slides with just some evidence from the REU study that we did in Uganda to give you a sense of how effective that was and a bit of motivation as to why we ran these separate saturation experiments. So this slide that I'm showing now shows the reduced prevalence of the impact of the REU project on reducing the prevalence of inadequate vitamin A intakes in 3 reference groups. So the first panel on the left where it says young children, we had 2 treatment arms, a Model 1 and Model 2. Model 1 was more intensive with distributed planting material for orange sweet potato and 2 years of trainings. Model 2 pulled back a bit on the trainings in year 2, and then there's a control group. What you see there is a 31 to 34% increase in the proportion of children that had inadequate vitamin A intakes in their diet. So that's as a result of the REU project. So it's a very large effect. If you shift over to the women on the right-hand side, again, between 26% and 36% reduction in prevalence of inadequate vitamin A intakes in that reference group. Again, a very large effect and very successful at getting more vitamin A to women and reducing the proportion of women that don't have sufficient vitamin A in their diet. We didn't find a significant effect for the reference children that were aged 3 to 5. That's our kind of middle group. And in that case, it was in part because there was a secular improvement or reduction in the prevalence of inadequate vitamin A in the control group due to other factors, and so we didn't see a separate effect there. Still, overall, it's a very successful intervention to improve dietary intakes of vitamin A. Next, I want to show you some impacts on adoption. So in these 2 figures, you see adoption rates for orange sweet potato among on the left-hand side among treated household members. So these are members of the project over an 8-season cycle. So with 2 seasons a year in Uganda, this is over 4 years. The first 4 seasons represent the 2 years of the REU project. The next 4 seasons represent the first 4 seasons after the REU project had ended. And so if you look at here, in season 1, in the left-hand side panel, so these are beneficiary households, these are project households, okay? So you see very high adoption rates. Essentially everybody got access to the planting material and they planted it in our 3 districts, Kamuli, Bukedia, and Mukono. Over time, you see that in Bukedia, there's a decline in adoption that's quite steep. In Bukedia, sweet potato was less of a key crop, and also less important in the diet, so they didn't stick with it as well as in the other 2 districts. In the other 2 districts, there's a bit of a decline, which represents some experimentation going on during the project where farmers will try it out, and we don't expect necessarily 100% of farmers that receive the crop to keep growing it. They experiment, and those that choose to keep it will do so. But if you look even 4 seasons after the end of the project, you still have more than half of farmers, and it's above 60% of farmers in Kamuli and half of farmers in Mukono still growing orange sweet potato. This is 4 years, 8 seasons after they were given 20 kgs of vines. In Bukedia, it really drops off. There's some lessons there about that may not have been the best place to, or that it's possible that there are places out there that are not going to undertake the same interest and adoption. But still, some very good success among treatment households. Now, shifting to the right-hand side graph, non-beneficiary households, you see really broad spillover effects of the adoption. So these are households that were not in the farmer groups that were in the project, but were living in the same communities. And in the first season, in all 3 districts, at least half of people in our sample that were not in the project farmer groups received planting material and actually planted it. And if you look at, again, in Mukono, you have still, at 8 seasons later, 50% of households that are not part of the project, but in the same communities, still growing orange sweet potato. And in Kamuli, it starts to drop off. But what I want to kind of impress upon you is the presence of really large spillover effects. It's very easy for farmers to share orange sweet potato planting material. They like to do it. There's not a lot of transaction costs. This is a great news for Harvest Plus's biofortification program there because people are sharing the planting material. Scott McNiven's motivation here was that he thought, well, let's harness that and actually see if we can, what's the right level of coverage of a community then that would allow us to get even higher rates of sustained adoption. And so that was the motivation for doing the saturation experiments as part of the DDBC project. So Harvest Plus scaled up biofortification in Uganda in the DDBC project with a target of reaching, and they did reach, 225,000 households across 13 districts from 2012 to 2017, delivering both orange sweet potato and high iron beans. And IFPRI worked with Harvest Plus to conduct this impact evaluation, testing various strategies to promote diffusion and adoption. These are our main research questions. So are these 3. First, can spillover effects be harnessed to sustainably increase adoption rates? Second, are opinion leaders more effective at promoting adoptions? So as we were looking at the important role of farmer groups in the adoption story, we thought, well, there are also key opinion leaders in each community who may be, in a way, kind of uniquely good at promoting adoption of planting material. And so in the surveys, we identified those individuals and then ran a separate program where we tried to get them to help us promote adoption of the planting material. And then the last question is, how does the rate of saturation of planting material in project communities affect overall adoption rates and spillover to non-beneficiaries within the same community? So by saturation, I mean we'll define saturation as the proportion or share of the community that gets access to planting material directly from the project. And what we suspect is that as you increase saturation, so if you look at the graph, as saturation increases, we expect that, so as the proportion of households in the community that get access to planting material increase, we expect the adoption rate, sustained adoption rate in that season and later to increase as well. But we do expect a kind of declining path there. So as I said, because not all households will continue to grow it, they have a comparative advantage in other crops or maybe outside of farming. And we're really looking at kind of where that kink in the curve is. So at what point does it not become valuable to continue giving planting material out? And in particular, because spillover effects are large, we know that actually directly giving plant material to 100% of households in the community would not be the most cost-effective approach. And ultimately, that's what Harvest Plus, that's the question Harvest Plus needs to answer, is what's the most cost-effective approach to getting very high adoption rates at the community level. So we think there's probably some intermediate level of saturation that will help us determine that, and that's what we've tested today in this project. So here's our study design. We put together an experiment that varies who in the community gets access to planting material across 4 treatment arms. In 3 of those treatment arms, planting material was given to the Harvest Plus selected farmer group in that community. This was the same methodology that was used in the REU, and it was very successful. And Harvest Plus wanted to keep with the same delivery strategy, the core delivery strategy of working with farmer groups. So the low saturation arm provided planting material to all members of the farmer group, plus 20% of all other households in that community. So in our baseline survey, we actually did a community listing of all households in the community. We identified farmer group members. We gave all of them planting material. And then we randomly sampled 20% of all other households, so 1 in 5 of all other households, and also gave them access to planting material. So that's our low saturation treatment. The high saturation treatment was to give planting material to the farmer group members plus 50% of all other households. So literally half of all other households in the community also got access to planting material. So that's a lot, right? You have the farmer group members plus 50% of everybody else. Well over half of community members are directly getting access to planting material from the project. Next was our thought leader treatment arm. So in the community listing, we asked people to identify opinion leaders in farming and in health, and also people that they consider to be progressive farmers. In each community, so we kind of, in a way, we ran an election, essentially, for who is very good at being opinion leaders and progressive farmers. We took the 6, so in each category, we took the top 2 vote getters in this election, so to get a total of 6 individuals that would serve as our thought leaders to help to promote diffusion in those communities. And then last, our comparison group was the main DDBC project itself, which was giving planting material only to the farmer group members in that community. So the DDBC project was building off the evidence from the REU about the success of that model. And what we're experimenting with here is to see, great, let's use that model, and that's our comparison group, and then let's add additional structures to promote diffusion and see if through higher saturation or through working with opinion leaders we get different results. Just to be clear, the thought leader treatment arm does not have any, farmer group members are not given planting material directly, only through the thought leaders. Our study design is a randomized controlled trial, so the control here in quotes is the DDBC project communities. And we took a list of communities and randomly assigned them into these 4 treatment arms. Here's a graphic that basically describes that study design. So in the low saturation arm, if you look at the graphic, the large oval represents the community, the smaller oval represents the farmer group, and those dots that are orange represent households. Each dot represents a household. The orange ones are those that got access to planting material. So if you look at arm 1 and arm 2 in the farmer group, all households get planting material. If you look outside the farmer group oval into the broader community, in the low saturation arm, 1 out of 5 households get planting material, and in the high saturation, 1 out of 2, every 2 households gets planting material. And if I jump to arm 4, you can see that only farmer group members get planting material, and in the rest of the community, nobody does. So what we're going to do in the saturation experiments is look at the effects of, we're going to compare the adoption rates of treated non-farmer group members, so those orange dots that are outside the farmer group circle. Those are treated non-farmer group members, and see how the project affected their adoption rates. And then we're going to look at effects on untreated non-farmer group members. So those are the blue dots outside the farmer group circle. And those are essentially our spillover recipients. And we want to see to what extent they received, whether there was a higher adoption among those non-beneficiaries in the low saturation and high saturation treatment arms, which represents a larger spillover effect or return to saturation. So that's what we'll be testing, and to answer question 3, that's really the main motivation for this study. But we also wanted to give a serious effort to this opinion leader approach, where rather than working with farmer groups, we deputize these 6 individuals and ask them to help us deliver planting material across the community, and they kind of select their methodology and roll it out. And so they can be giving to people in the farmer group or outside the farmer group. Okay, let's look at results. Briefly. We collected data in the first community listing in 2012, our baseline household survey in 2013. We did kept an entire group of a community listing in the N line in 2015, and then worked with the overlapping sample for our analysis. We focused on households with children under age 5 in the baseline, and with households with children under age 8 in the N line. And we stratified the sample to make sure that we had both farmer group members, treated non-farmer group members, and untreated non-farmer group members to capture the spillovers. Okay, so here's my first set of results. And here what we're reporting in this table is the treatment effect of the saturation treatment. So this is the effect of being a non-farmer group member in the low saturation or high saturation community and receiving planting material on the probability that you adopt orange sweet potato or high iron beans. So the first 3 columns are for orange sweet potato. The next 3 columns are for high iron beans. And we're reporting the effect on adoption rates in 3 different time periods. So our entire study design covered 5 seasons. So the first column is the last 5 seasons. The second column is just the last 2 seasons, so the last year. And then the third column is the last season. So we're adjusting time periods up to the present, essentially, which is the period of the N line in 2015. So if we look at the first row, the combined saturation treatment, so this is the average effect of being a non-farmer group member household who was randomly selected to receive planting material in either the low saturation or high saturation treatment arm. It's the average increase in the probability that that household would grow orange sweet potato or high iron beans in this period. So if you look at the effect over the last 5 seasons for the combined saturation treatment for orange sweet potato, 35% of households that were not in the project farmer group but received planting material grew orange sweet potato over that season. That's exactly right, because that's exactly what we expect, I should say, because that's the average saturation rate. So our low saturation rate was 20% of households. Our high saturation rate was 50% of households, so 35% is right in the middle there. And it basically just kind of confirms that the project successfully rolled out this saturation treatment experiment, and that 35% of non-farmer group member households did actually receive planting material and plant it. The next thing to notice, so that's true both for orange sweet potato and for high iron beans. So it's a nice kind of validation that our study design was rolled out with fidelity, that we kept to it, working with Harvest Plus and with NGO partners, 5 NGO partners. So we're grateful to them for their help, and we were able to show that it worked. If you look at the adoption pattern over time in that first row, you see that adoption does decline among this group of non-farmer group members, and it declines pretty steeply from 35% to about 16% and then 14% in the last season for orange sweet potato, and a bit similar for high iron beans. But it's important to know that there's still a high rate of adoption in these treated non-farmer group members, and it's still significantly higher than it would have been if they were just in the regular DDBC project in the control group. So the fact of directly giving planting material to non-farmer group members meant that 5 seasons later, they were still significantly, and I would say substantially, more likely to be growing orange sweet potato or high iron beans. Next, if we look at the next 2 rows, you can see that we divide up the effects between the low saturation treatment and the high saturation treatment. And the patterns are pretty similar. You still see high adoption in both. The adoption rates are not actually dramatically higher in the high saturation than the low saturation treatment arm. And then they do decline over time, but stay significant in both for orange sweet potato. For high iron beans, the adoption rate actually tails off in the last year and the last season. We don't see a significant difference between their sustained or their continued decision to grow high iron beans in the last year. And we don't know if that's some type of congestion effect from having so many people around you with beans, but it does tail off there. Okay, so that's the main treatment effect on households outside the farmer group who received planting material. Now I want to look at the spillover effects to those blue dots in the picture. So these are households that were living in the same communities but did not directly receive planting material. This is the effect of being in the low saturation or high saturation treatment arm on the probability that those households got access to planting material and grew it. And what we see here in the first row is a combined saturation spillover effect of 16% over the last 5 seasons. So 16% of non-farmer group households who did not get access to planting material from the project actually grew orange sweet potato in the last 5 seasons. That is evidence of a saturation spillover effect or returns to saturation. So it demonstrates that giving planting material to more households in the community outside the farmer group has positive spillover effects on non-farmer group members. And just to be clear, this is relative to the spillover effects that existed for the DDBC project. We expected substantial spillover effects. As I showed you in the REU model, about half of households that weren't in the project in the REU actually got access to planting material. So this is an additional spillover effect from these saturation arms. And you can see actually the mean in the control group. So you can see that 37.6% of households who were not in the DDBC project farmer group in those communities actually got access to planting material and grew it for orange sweet potato. So there's an additional 16% jump in the spillover effect. And that spillover effect is fairly stable. It declines only a little bit actually over the 5 seasons of the project. Similar pattern for high iron beans, a little bit higher spillover effect from saturation, and it declines a little bit more quickly. And what's also interesting here is that the spillover effect is larger for orange sweet potato in the high saturation spillover communities than in the low saturation communities. And that difference is actually statistically significant. So it looks like high saturation spillovers, so that 50% coverage rate outside the farmer group, actually does have substantially larger spillover effects. Over time, it tends to converge, but at least initially, it's substantially larger for orange sweet potato. It's larger, but not as large for high iron beans over the last 5 seasons, and then that difference actually falls away in the last year. Okay, next, I want to show you results from the treatment. This is, again, just looking at spillover effects. So these are basically anyone in the community who was not part of who did not directly receive planting material, and there were only 6 individuals that received planting material. What we find is that in the opinion leader and progressive farmer treatment, so if you look at row 3, the average effect on spillover rates into other household members in the community is no different, and in fact, it's numerically negative compared to the DDBC farmer group approach. So opinion leader and progressive farmer treatment was not very successful. It didn't do better at promoting adapting material than the DDBC farmer group approach itself. And if you look at repeating the results from the low and high saturation spillover, they are much more effective, and the bottom row there shows that those differences between the high saturation spillover effects and milliliter effects are statistically significant in all time periods for both crops. Okay, briefly, I want to just mention the cost estimates. So we looked at cost effectiveness of the 4 different treatment arms. And Harvest Plus generously gave us their time to help us collect the cost data for their cost of implementing the project. So what we're presenting here in Table 6 by column is the implementation cost per individual household of the DDVC project by treatment arm. So for DDVC itself, this is per household that received planting material. The cost was roughly $114 to do this delivery and all of the supporting training, both in agronomy and nutrition and related information to help farmers succeed. So that's the cost during the project, over the life of the project, but we know that a number of these households are going to continue growing orange sweet potato and high iron beans. So average costs per beneficiary actually will continue to decline over time. So in some ways, this is kind of the $114 figure is sort of the highest figure. In high saturation and low saturation treatment arms, you see those costs per beneficiary drop substantially because now we're adding a lot more beneficiaries in the same number of communities. And the marginal cost or incremental cost of adding a few more households, or maybe even a lot more households once you've reached the community, is relatively low. So you see the lowest average cost in the high saturation treatment arm. This means that the high saturation treatment arm, which was in all of our estimates at least as effective as the low saturation arm, and generally more effective at promoting spillover, is the most cost effective of the strategies. So that's the main takeaway of our costing results. So let me just conclude then that the small added cost of distributing planting material for the biofortified crops to other farmers and communities outside the farmer group led to much higher rates of adoption in the treatment in those households receiving the planting material, and also higher spillover effects, and essentially demonstrate returns to saturation. So we conclude that the natural diffusion process can be harnessed to substantially increase adoption rates over 5 seasons. We don't, in general, find many significant differences between the low saturation and high saturation rates, but something between 20% and 50% of saturation rate of covering households outside the farmer group appears to be optimal, and there's nothing here that would argue against doing this at the 50% level. We don't have in the results I'm showing you today, we don't do much to explain what's driving this. So is it more information that people are learning from each other? Is it access to planting material? We haven't exactly differentiated the impact pathways here. But at least we think that there's important evidence as to what's going on and the potential of much higher saturation rates. What's very promising about these results is that as a public health intervention targeting reaching as many households as possible in the community, it looks like high saturation really seems to be promising as a strategy to make sure that many more households in the community sustainably adopt biofortified crops. Okay, thank you. I'm going to stop there, and let's have some discussion or questions. Thank you. Hello? Hello?
Yes, hi Dan. I'm going to unmute the participants so that they can ask their questions. I'll ask if the participants, if you do not have a question, go ahead and self-mute so that we can hear what's going on from everyone else. So
thanks, good
everyone should now be unmuted unless they've muted themselves. So feel free to ask questions. Identify yourself, please. Hello, hi, may I ask that if you do not have a question, you can unmute yourself.
Define the cost of transport. What you have
Martin?
Unmuted.
when I look
Hi, I'm,
Martin, are there any questions from your room?
Dan, hello, how are you?
hi, Jan. How are you? Good to hear
Great.
you.
Thanks so much for doing this, and it was a great presentation.
Thank you.
My question is, one of the rationales for working with farmer groups is that in theory they would have prepared their plots before the arrival of the planting material. There would be some preparation and training. And so you would figure when you're doing a saturation approach and giving to these other 20 or 50% of households that kind of pre-preparation, was it done so the households knew the material was
Yes, Jan.
so I'd be interested in how the implementation was done, because those are really interesting results. And I would like people to know what was the implementation that was done, because oftentimes in mass distribution, without preparation, we see a high loss of planting material.
Now, Jan, that's a great point. Thanks. So we worked very closely with Harvest Plus and the NGOs to train them in the strategy of essentially conducting this experiment with us. And so in the low saturation and high saturation communities, the non-farmer group members that were selected for the project were invited to the same kinds of trainings and were encouraged to prepare their fields and things like that. So this wasn't like a sort of surprise event where we kind of showed up and kind of identified them and said, I'm handing you some planting material. We really took some of the same approach to preparing them and getting them ready to receive it. Now, farmer group members provide and farmer groups provide sort of a unique structure to support that, right? And so that's why we keep that structure as our kind of comparison group and then add the low saturation, high saturation on that. So it's true that what we're seeing is the benefits to some extent in the low saturation, high saturation arms of having the farmer group there almost as hosts. But then the non-farmer group members essentially do very well in that setting.
Okay, thank you, Dan.
Yeah. Hi, Dan. This is Srini. I work here at SIP as agricultural economics. This is regarding the
Hi.
hi. This is regarding the sample size that you have identified. I mean, you said you got a 20% and 50% saturations, and how did you come to that particular numbers, and why did you do that? I mean, the low saturation 20% and high saturation 50%.
Yeah, thanks for that question. So to be honest, those choices were somewhat arbitrary, but I'll tell you what our thinking was. First of all, we knew that, as I mentioned, 100% saturation of the community can't be cost effective. The spillover effects here are so large from the REU, half of all households getting access to planting material that were not part of the project, that we didn't think that effectively flooding the community was the right approach. So we wanted our highest saturation rate to be well below 100%. We considered rates higher than 50%, but ultimately decided that 50% was, in some ways, if it was successful at that rate, that was going to be a smashing success. Then after that, you want saturation rates that are not too close together. We don't learn a lot if we have a saturation rate of 40% and one of 50% and learn that the difference between them is small. So we chose 20% as a much lower level that we also thought might be close to kind of what might be scalable if the 50% kind of didn't show any effects and there was a big declining returns to saturation. Then 20% might be kind of a good 1 in 5, a kind of good rule of thumb for the low saturation. And again, different enough from just farmer group member comparison group to be worth the comparison.
Thank you, Dan. Thank you so much.
So we have another question for you, Dan.
Hello.
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 This is Ted Carey. I have a question.
Yes, hi.
Hi, I'm a sweet potato breeder in Ghana, and I'm interested in the quantities of planting material that were given to, you know, your basic group and your spillover groups or your saturation groups. Because I think at the beginning, I heard you mention that you were giving 20 kilos of sweet potato vines to each household, and that seemed like a lot to me. And so I just wonder if there's any, you know, any like information about how much how much adoption you can get with less amount of material.
Okay, thanks. That's a great question. So, and I'm sorry I didn't mention it during the presentation. So the 20 kg 20 kgs of sweet potato vines, orange sweet potato vines, were given out in the REU project, the one that preceded these experiments. And it was a lot of planting material, but really wanting to make sure that the supply of planting material was not going to be a constraint to promoting adoption. And as you saw, still in a couple of communities, half of households still growing it in a couple of districts 8 seasons later. So that's kind of, to me at least, suggestive evidence that giving a lot is a good approach. In the DDBC project, they gave 15 kilos of orange sweet potato and 2 kgs of the improved iron beans. So the rates, anybody that was a beneficiary in the farmer group treatment or the low saturation or high saturation treatment got that quantity of planting material on average. So there was good fidelity to that in terms of distribution. In the opinion leader treatment, we gave them enough planting material to give it to share with an average size farmer group. So we essentially normalized the amount of planting material given to be the same amount of planting material as the average farmer group comparison treatment got. So the same as an average DDBC project community would get. So it's basically 15 kgs of orange sweet potato vines times 22 households on average in a farmer group.
Hello, I am Julius Okello. Can I come in with a question?
Yes, please. Sure.
Thank you, Dan. Thank you for the great presentation. I'm Julius Okello, agriculture economist based in Uganda. I had the same question that Ted asked, especially because of the often observation that planting materials, when sufficient, dry up, and therefore farmers do not tend to have sufficient material to plant in the subsequent seasons. And especially when the farmers are given material just to establish and then to grow in subsequent years. But I think you have answered that question. Thank you. I have two questions. One is regarding Bukedea. I am not just very sure what exactly what was going on in Bukedea. I suppose that the project was implemented in areas where sweet potato is grown, and therefore that the observations in terms of adoption rates were expected to be similar. So what exactly was driving the difference, the massive difference in Bukedea? And the second question is to do with the opinion leaders. What was the strategy that they were supposed to use in disseminating or in distributing the material? Was there a specific strategy, or were they just given the material and asked to find out how they can share it, or there was a specific strategy for distributing the material that came through them? Thank you.
Yeah, sure. Those are good questions. Thank you. So the results that I showed early in the presentation from Bukedea were from the original REU impact evaluation. And, you know, I think there were a variety of factors that drove the decline in adoption in Bukedea. And, you know, I think we had a representative sample of households in the project there. But as I said, if you look at the baseline characteristics of those households, they were much less likely to be growing sweet potato than in the Mukono and Kamuli households. and less likely to be consuming it. So it was still an important secondary crop, but not nearly as important as in the other communities. The conditions there were a bit drier, and there was also some difficulty in access to, or some, there were some dry seasons there in the middle of the project. So the households in the other districts were able to recover from those dry seasons much better. There were a few households in Bukedia that kind of took this up and made a business out of it and began selling orange sweet potatoes. So you actually see a significant, it's about 8 or 10% of households in the end line continue to access orange sweet potato through purchases. So there was a little marketing kick there in Bukedia, but the adoption story was much more negative. On the opinion leaders and progressive farmers, so they also received training in how to, similar to the farmer groups and the treated non-farmer group members, they received training in how to grow the planting material and some related nutrition training, but for a very short period. And trained on how to prepare their land and things like that. And then we're encouraged to go out and share that information and the planting material with households when they received it. We think part of the weaker effects there are driven in part by the fact that, just the scale of operation to share, more than 300 kilos of orange sweet potato planting material, for example, was just a big job for those households. It appears that they kind of, if you look at our data, they shared with relatively fewer households, gave more planting material to fewer households, which to me suggests some kind of congestion or just kind of exhaustion effect where they couldn't really easily distribute it to a very large number of households.
Yes, Dan, thank you very much. We are having the last question in the interest of time, and this time it is a lady. I have had so many gentlemen. Can you please?
Hi, Dan.
Thank you, Charles.
I guess it's very interesting for me to see how data saturation can lead to greater and sustainable adoption, and especially with regard to public health interventions. But one major question that I wanted to ask was just looking at that, was it just distribution of the vines, of the planting material, sorry, or was it just, was it accompanied with other interventions or strategies like SBCC? I'm not sure what that component of the intervention was. And the last one was, how did you ensure that the farmers in the treatment arm were not originally planting some of these crops that you mentioned? Thank you.
Sure. Yeah, so no, they did receive, in addition to the planting material, they received pretty substantial trainings on how to prepare their fields and then how to grow it and maintain it over the season. So the DDBC project had a fairly robust training module on planting both crops and maintaining them. There was also a nutrition component to improve their knowledge about the benefits of growing the crop and how to prepare it, how to cook it and consume it, and the benefits of consuming it. So, there was a lot of support for that. Regarding kind of specific agronomic messages, for example, I'm not the right one to be able to fill that in, unfortunately. Sorry, your second question was?
Is how you ensured that the treatment arm was not previously growing.
Sorry, you cut out.
The treatment arm, how you ensured that they were not previously growing.
Yes, thanks. So we didn't control, so it's possible that they could already be growing orange sweet potato, in part because the REU had really promoted a lot of diffusion already. And so that was the case, and our job wasn't essentially to make sure that they weren't growing any as much as to make sure that that was balanced across the 4 treatment arms. I don't remember, there was some orange sweet potato already in the fields in a low proportion of households in our study. I mean, the study districts were selected in part because they weren't major districts in the original REU project. So I can't remember what the initial adoption rates kind of at baseline before the experiments began. I think it was just below 10%, maybe 8%, but I'd have to go back and check our numbers. But there was about that level of prior adoption on average across the sample. The way we did our design was just to randomly assign the 4 treatment arms across the study communities, so we essentially balanced that out.
Yeah,
so that wouldn't in any way be
actually those districts
contaminating.
where there was no sweet potato intervention below.
Done.
So thank you.
That's right, Charles.
Yes, thank you very much for the opportunity to present to us these results and the questions. We had many, but almost because of time, we are short. So other lines.
No, I
have a question.
Other countries can stay on line because we are going for another session. Thank you very much for the input.
Dan, can I ask you a question?
Applause.
Elsewhere.
They can continue, but we want to go into another session.
Yes, we can continue online, but for those of you who have to go, you can go ahead and disconnect. And those of you who can stay online, we can continue until maybe another, Dan, is 10:30 your cutoff?
Yes, that's fine.
10 minutes?